Hi, in this video we will see that invertibility of matrices can be formulated in terms of their rank. Let us start with the matrix. So let A be a square matrix or a n by n matrix. Well, then A is invertible. You remember what was invertible? So A is invertible if, or it has inverse if there is another matrix which we denoted by A inverse, but let me just write B, such that this is just definition. AB or BA is equal to identity. We studied this thing in details and we saw that this is the same thing as, or let me just write it like this, that if we row reduce this guy, the row reduced echelon form of A would have n leading one. In other words, the row reduced echelon form of A is the identity matrix. And actually we use this trick that you put AI and then row reduce it, then identity A inverse will appear there. So identity matrix, in other words, you will have 1, 1 on the main diagonal and everything else will be 0. Now that we know what is the row reduced echelon form of an invertible matrix, then we just count the number of leading ones and that will give you the rank of that matrix. Yes, so identity matrix, remember, is row reduced echelon form, and then you count the number of leading ones. Each row has one leading one, and this is n by n matrix. So this can be written in terms of the rank, and it will be rank of A is equal to n. So a matrix is invertible if and only if its rank is n. And further, we can just see that when you have invertible matrix, the system, this is also another version of this, the system AX equal to B, we can always remember the inverse method. You can find always A inverse B, this unique solution. So this has a unique solution no matter what is B for all B. So every B you give me, I will find A inverse, multiply that to B from the left. That will give us the solution of the system. And when you have a homogeneous system for this case, so it means that AX is equal to 0. So you see here, if I have A inverse times 0 vector, it's going to give me 0 vector. So this means that this is X, the solution, has only trivial solution. So these 1, 2, 3, 4, 5 conditions are equivalent. So whenever someone tries to check a matrix is invertible or not, you can start with this definition, which was, well, difficult to check, or you can check it by row reducing the matrix and seeing if it is identity or not. Or if you know that the rank of the matrix is n, or if you know that for every AX equals to B, it will have unique solution, or AX equal to 0 has trivial solution, only trivial solution. These are equivalent conditions for an invertible matrix. And specifically, we saw that the invertibility of the matrix can be written in terms of the rank of that matrix, all square matrices.